All right, so we finished up with problems 14 through 23, and now we're ready to finish up this particular packet. We'll do 24 to 30, and those will be due next Friday. So here, I'm not going to talk about all those problems in detail because I've already done that in a different video, but what I want to do here is I just want to tell you what I expect you to do just to get the ball rolling. So these are the things I need you to do before I can help you with the rest of it. Okay, so this is your prep work. But before we do that, I just want to talk briefly about what each of the problems is. That's it. So let's take a look here. Number 24, it's about Una. She's purchasing candles. She's got good candles and cheap candles, and the good candles burn longer than the cheap ones. And then there's a question in there that asks about the height of the candles at a certain time. Right? Well, let's take a look at what I want you to do for that one. For that one, let's go back here. I want you to copy a chart. So over here, there's our chart. Looks right here. It's a timeline down the side. Use your grid paper to make sure everything looks pretty. And then we've got a timeline for the expensive candles and a timeline for the discount candles. The discount candles run out after 3 hours, and then the good candles run out after 5 hours. And if you get that much down, I can help you with figuring out how to answer this question. All this stuff here, by the way, read it, but don't copy it all down, right? It's not part of what I'm asking you to copy down. Just a timeline with these two intervals, one for each type of candle. Next, number 25. So this is a problem involving equidistant points. It's exactly like number 15, actually. It's pretty much the same problem as 15, just with different points. So here, all I'm asking you to do is just copy down the points. And that's the bare minimum. Right? Now, a lot of you should be able to do more than that. Specifically, verify that the distance from A to P is the same as B to P. In fact, I fully expect that some of you should be able to actually finish this whole problem on your own without any assistance because you've already done 15. But again, at the very bare minimum, if you could just plot the 3 points on the coordinate plane, we can get started. Next, we've got number 26. So finding points on the y-axis that are so far away. So here, all I need you to do is to copy down this diagram. And by the way, this point up here, y is, so from here up to y is about 5.5 spaces. So that point on the y-axis is not exactly, a whole number. It's about 5.6. And so from here down is also about 5.6. So it's going to be a little less than a full space below the x-axis. I know the grid gets washed out. So again, from here all the way up is about 10.5 spaces to that point, and down here is about a half space below the y-axis. So if you copy down the point, draw the grid, and draw these 3 lines in, I can help you from there. Next, we've got 27, talks about lattice points. Lattice points, and that's one that I definitely wanted you to take a look at here. I want to talk about what lattice points are. So, oops. Okay. Lattice points are when you've got a grid like this is a lattice point, and that's a lattice point, but this is not a lattice point, and this is not a lattice point. So lattice points are just places where the grid lines meet. That's it. Right? And they're handy because since we can count spaces on the grid, we can tell exactly where a lattice point is. We can calculate, either by counting spaces or using the Pythagorean theorem, exactly how far apart 2 lattice points are. If the point is not on the grid, if it's right here and say right here, I really can't calculate how far apart those are because I don't know really where they are. Whereas here and here, okay, since they're lattice points, I can draw in my triangle. I've got my 2 legs. I can do my calculation. I can figure out how far apart they are. So speaking of which, this question wants us to find 2 points that are square root of 13 apart. And then it asks about finding the square root of 15. And then is it possible to form a square whose area is 18? So, but starting with square root of 13 and then looking at square root of 15. So I'm going to ask you to find 2 points that are that far apart. And when I say find, you're going to have to look for it. Right? You're just going to have to poke around and see if you can find it. And here's how I would recommend that you go about it. You just get a piece of grid paper, and then I'm just going to pick 2 points. All right, there we go. There's 2 points. So I'll connect them. See, are they square root of 13 units apart? Well, let's find out. So I'll draw my triangle in. I have 1 and 2, so that's 1 squared, and 2 squared is c squared. 1 plus 4 is c squared. 5 is c squared, so square root of 5 is c. So these two are square root of 5 apart. So no, not square root of 13. So square root of 13 is going to be a little bit bigger. On my calculator, if I check, it's like 3 point something or whatever. So it's going to be a little bit bigger than this. So let's try maybe going over, I don't know, let's try this. I'm going to go way over here. Those 2 points. Let's try that out. So draw my triangle in and up. That's 4. That's 1. 4 squared and 1 squared is c squared. I've got 16 plus 1 equals c squared. 17 equals c squared. So square root of 17 is c. So that's square root of 17. That's too big. So we need to come in a little bit. So you're just going to have to keep trying and kind of poking around. I mean, you don't have to, it's not completely random. I know a square root of 17, so I better not like continue stretching that out further. It's just going to get worse. So you're limited. You're not going to have to keep looking forever, but you're going to have to try several before you find it. So if you come to me and you're like, I couldn't find it, like, let me see everything you tried. Okay, so I will need to see the work that you tried. And you will if you give it an honest effort to find it. All right, so that is number, let's see, 27. I'll give you a little hint here, but again, the grid got washed out, so it's terrible. All right, 28. 28 is a whole bunch of terminology, and it actually only asks one question at the very end, and it asks, what can you say about the measure of the 2 non-right angles in a right triangle? And the key to that is just knowing what the 3 angles in a triangle add up to anyway. Let's go to the guide here. All right, so our 3 angles in a triangle, they have a sum. If one of them is a 90-degree angle, and I just take that out of the sum, then the other 2 must add up to complete answer sentence. You can do that on your own. Let's see, 29 is, 29 is a complicated one, so let's take a look. So 29 is talking about, we have drawn, I'll give you a, let me go back here and show you again. Okay, we've drawn a bunch of shapes there in the coordinate plane like this. Okay, and we've claimed, or I have anyway, I've claimed that they're squares. Well, we don't know that they're squares. I mean, I can do the Pythagorean theorem and calculate that those are all the same length, but to be a square, I also have to know that these are all right angles. Right? We haven't talked about that yet, and that's what this problem is all about. Essentially, what we're trying to figure out is if I construct this diagram in a particular way, and it'll, then how do I know that this angle right here in the middle is a right angle? So what I'm going to ask you to do here to kind of get the ball rolling on it is I need you to copy down these 4 diagrams. I would recommend these 2 up towards the top of the page, and these 2 bring them down so that they're kind of towards the middle of the page, and leave a little room underneath because you're going to have to do some calculations. Specifically, I think you can also do this yourself. I want you to calculate the slope of RQ and QP for each of these. And make sure you label everything. Label, label, label. Okay? Label everything. So again, you're calculating the slope of RQ and QP for each one of these, and just put it underneath. And that'll be a good start, so we can get the ball rolling if you can do that much. Let's see. And then finally, there's number 30. Find an example of an equilateral hexagon whose sides are all square root of 13 units long. Give lattice points coordinates for all 6 points. So we've already found, if you've done number, what was it, 20, 27. If you did 27, and you will get this if you work at it, if you do number 27, you've already found a length on the grid that is square root of 13 units apart. And so now it's just a matter of arranging 6 of those into a hexagon. So, for example, I'll go over here. I mean, if I did square root of 5, so I found square root of 5, I want to make a hexagon out of that. Well, let's see, I'll go, there's one of them. I'll come over here. Maybe go out this way. Come down here. I'll see 1, 2, 3, 4. Maybe if I went down here. Oh, but then that's kind of like one continuous side, so that doesn't really work, right? So let's try something else. I got 1. I got 2. Let's see, maybe I come back in this way. There's 3, 4, 5, 6. Oh, there's a hexagon. 6 sides. Okay. There's probably other ways I could do this. I think maybe if I did this and bend it out instead. Alright, so I got 1, 2, 3, 4, 5, 6. There's 6 sides. So just play around with it until you figure out how to put your 6 lengths together to get a hexagon. So, review for number 26, or 24, sorry. All you have to do is copy a chart. That's it. Not all the text, just the chart. Number 25, all you have to do is draw the graph, plot the points, right? I think you could do more, but if you do it that much. 26, copy the diagram as you see it there, keeping in mind, going back to the diagram for this one, this point up here should be about 10.5, 10.6 units above, so it's not right. It's not a lattice point. And this one here is about 0.6 below the x-axis, so again, not a lattice point. Okay. So just copy that diagram. And then for number 27, just experiment around until you find 2 points that are square root of 13 apart. Do the same for square root of 16. Oh, for drawing the square, find 2 points that are square root of 18 apart. All right, I'll add that here. I'll put also square root of 15, square root of 18. So just experiment until you find those. Number 28, answer the question in a complete sentence. I pretty much gave you the answer a moment ago. But if you look at the guide, you should be able to figure it out. 29, copy down the 4 examples and calculate the slopes of RQ and QP for each one. And then for 30, well, if you've already done 27, all you have to do is play around until you can connect 6 segments of that length into a hexagon, which you should be able to figure out how to do. I think you can do that on your own. All right. And that is homework. We should have all this done by Monday. All right, good work. That'd be Monday the 20, whatever, Monday.